Hello and welcome to the Motor Project by Brady and Daniel. Here is a video of our completed motor. In this video, we will cover two parts. The first part will be how to construct our motor. The second part will be the theory behind our motor. The first part is how to construct our motor. First, I will cover the list of materials needed. These will be copper wires, magnet wires, battery holder, which holds 4 AA batteries. Each of these batteries contain 1.5 volts. We'll need 2 alligator clips, 2 rectangular magnets, 2 chopsticks. These will be used to support your motor, a styrofoam board, and finally 2 plastic holders. In the picture on the top, you can see the magnet wires wrapped in a loop. Here is a picture of the styrofoam board. On the top right, you can see a picture of the 2 alligator clips attached to the battery holder. Inside the battery holder, you will find the 4 AA batteries. Here is a picture of the 2 plastic holders. Here is a picture of a chopstick cut in half, thereby creating 2 chopsticks. And finally, on the bottom right is a picture of the 2 magnets. The first step in preparing for the construction is to connect a styrofoam board, wooden chopsticks, copper wires, 2 plastic holders, and 2 magnets. Next, we will create 2 holes near the sides of the styrofoam board and stick the wooden chopstick in the hole. But before you stick the chopstick in the hole, it must be cut in half to ensure a smaller net sticking out of the hole. Here is a picture of the cut wooden chopstick. It is cut in half to create 2 chopsticks. The next step is assembling the copper wire. First, tie together several strands of copper wires to form one thicker strand of copper wire. This will be about the same length as the cut chopsticks. We will make 2 of these strands of wires. You should make sure that the ends of the copper wires do not have any insulation. Scrape off any existing insulation if necessary. Although any existing insulation in all areas need not be stripped. Then attach the 2 strands of copper wires to separate chopstick posts by taping them together with tape. You should leave some space between the bottom of the copper wire and the styrofoam. Then curl the bottom ends of the copper wires, making a J-shaped hook. The 2 copper wire hooks serve as a supporting platform for the magnet wire loop to be made in step 5. Next is to insert the magnets. The 2 magnets can be inserted in the center of the styrofoam board, forming a perpendicular line to the parallel line between the two chopsticks. The two faces of the magnets facing each other must be of different poles. To determine the correct alignment, put the two magnets together and find the alignment of the face that attracts each other. Although you may not know which side is the North Pole and which is the South Pole, the net magnetic pole can still be determined. Here is a picture of the two magnets. Step 4 is to assemble the stable holders for the motor. You will tape the two plastic holders onto the styrofoam behind the chopstick poles, one on each side. This will make sure that the magnet wire loop does not move from side to side when it is spinning. On the left, you can see a side view of the motor with plastic holders attached. In the bottom picture, you can see a bird's eye view of the motor with plastic holders attached. Step 5 is to construct the rotating component of the motor. The main rotating component of the motor can be constructed using a magnet wire. First, roll the magnet wire into circular loops. The more loops there are, the better the result. However, ensure there is enough room at both ends of the magnet wire to wrap around the loops of the magnet wire. This combines the loops together into a thicker loop, creating a better result. After creating the circular loop, the ends of the magnet wire can be stripped of its insulation by scraping with scissors. Then, carefully place the magnet wire onto the copper wire. Works to ensure the magnet wire can be attached without stopping the revolutions of the magnet wire. Here are 3 pictures of the equipment. The tube on the top indicates the motor constructed using the magnet wires, which are attached to the poles. In the bottom picture, you can see a picture of the wire loops. Step 6 is to assemble the battery holder. The battery holder used to assemble the motor contains slots for 4 batteries. First, unscrew the lid of the battery holder and connect the batteries to the battery holder, ensuring the positive and negative direction of the battery aligns with the battery holder. After connecting, screw the lid on and using 2 alligator clips, connect one end to the battery holder. The corner of the wires on the battery holder indicates the signs of the terminals. The red color indicates positive, while the black color indicates the negative terminal. Finally, connect the alligator clips from the battery holder to the top end of the copper wires. Here you can see a picture with the batteries assembled in the battery holder. The 2 alligator clips are connected to the battery holder. The final step is to test and revise. This step is to test if the motor works. To test, you should turn on the battery holder and observe the results. You should make any modifications if necessary to suit your purpose. If it doesn't work the first time, don't give up. Just keep on trying. Here you can see 2 pictures of the finished product. Now I will pass it on to Brady, who will explain the theory behind our motor.
Here is a picture of our motor. When connected to batteries and turned on, conventional current flows from the positive terminal, which is the red wire, through the circuit and back to the negative terminal, which is the black wire of the battery holder. Current flows according to the red arrows shown in the picture on the right, down the copper wires on the left chopstick pole, across the loop, then up the wires on the right chopstick pole. As shown in the pictures below, conventional current travels counterclockwise through the loop. The two magnets facing each other will create a magnetic field with a direction originating from the north pole of one magnet to the south pole of the other magnet, because the magnetic field points from north to south outside a magnet. Although we do not know the corresponding polarities, we will assume that the direction of the magnetic field goes from the bottom magnet towards the top magnet, as shown in the picture by the blue arrows. Note that a reversed magnetic field will only reverse the direction of rotation of the motor. In the pictures below, we show both the current and the magnetic field of our motor. Here we have a bird's eye view diagram of our motor, assuming that the magnetic field points to the left of the page, represented by the B vector arrows. The magnet on the right acts as the north pole, which is colored in red, and the magnet on the left acts as the south pole, which is colored in blue. Once again, the magnetic field points from north to south outside a magnet. The brown loop in the middle is the magnet wire loop held up by the copper wire hooks, although the hooks are not shown in this diagram. In this position, the magnet wire loop is horizontal with the ground. In other words, the loop is laying flat. Looking from above, the conventional current goes counterclockwise around the loop as shown by the red arrow. In the following explanations, conventional current will be simply referred to as current. Let's look at a point at the top of the magnet wire loop. Here, the current flows to the left of the page. Since the current is parallel to the magnetic field, the magnetic force acting on this part of the loop will be zero. The same can be said about the bottom of the magnet wire loop. Even though the current points to the right side of the page at the bottom of the loop, the current is still parallel to the magnetic field. Therefore, the magnetic forces acting on the top and bottom of the magnet wire loop will be zero in this diagram. Let's then look at a point on the right side of the magnet wire loop. Here, the current points towards the top of the page. Using the right-hand rule, we can deduce that the magnetic force at this point of the loop points out of the page, as shown here. The dots represent a direction out of the page. Now let's look at a point on the left side of the magnet wire loop. Here, the current points towards the bottom of the page. Using the right-hand rule once again, we can deduce that the magnetic force at this point points into the page, as shown in the diagram. The X's represent a direction into the page. Combining the diagrams, we see that there are no magnetic forces acting on the top and bottom of the magnet wire loop. There is, however, a magnetic force acting out of the page on the right side of the magnet wire loop, and a magnetic force acting into the page on the left side of the magnet wire loop. The combined effects of the magnetic forces will create a net torque acting on the magnet wire loop. On the right side of the loop, the magnetic force pushes the wire loop out of the page, which is up relative to the ground. On the left side of the loop, the magnetic force pushes the wire loop into the page, which is down relative to the ground. The torque causes the magnet wire loop to start rotating counterclockwise through the axis formed by the chopsticks, if viewed parallel to the plane of the bottom chopstick. The direction of rotation of our motor is shown by the arrows in the picture on the right. The direction of rotation is derived from the previous diagrams.
Here is another video of the completed project. I hope you enjoy. That will be the end. Thank you for watching. Don't forget to hit the like button and subscribe. Thank you.